Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 5 a.m. on Saturday in London. We're broadcasting live from Thousand Oaks, California. Thank you so much for joining us. Tonight's topic is Jovian Vortex Hunter. We'll be back in 8.3 seconds. This is a Zooniverse project, and they said it best. Help us catalog interesting cloud features in Jupiter's atmosphere from JunoCam images. We are interested in determining the underlying fluid dynamics of that leads to formation of vortices and turbulent structures on Jupiter. That is straight from the Zooniverse page.
Yep.
You ready?
Yep.
Here we go.
Okay. We're seeing what should be pretty standard to all of you guys. Make it a little bit bigger.
Yay, Cliff's here. We can start.
Hey, Cliff. Oh, and so is Scott.
And so is Scott. Oh, good. Yeah. It's going to be fun. Thanks for joining us, Cliff and Scott.
Yeah, this has prettier pictures and better user interface. And it's got 2 data sets to work on, and they're both live. So, hey, that's good.
And there's the link. I will grab it in a second and put it in the chat so you have it, a clickable live link for that.
Okay, cool. Yeah, and they've got new data sets too. This banner was not up here yesterday.
Oh, way cool.
So it's helped them find interesting features in Jupiter's atmosphere. And as you see, 2 data streams, and we'll look at both of them because the first one's, they're both kind of basic. Lots of pretty pictures though, so I don't mind that there's 2.
Good. Yay.
Yeah. And 46% complete. They keep adding data sets, so that number's probably not going to go down too fast, or go up too fast.
No, Anthony's here too. Good evening, and glad I could catch you. We're glad you're here too.
Yeah. Hi, Anthony.
Thanks so much for being here, everyone.
Okay. Basically, this is JunoCam running, and Pam read this first bit about it, but it's oh, here's what Pam read. Yeah, it's JunoCam. They've got a bunch of images of Jupiter, and it's the images themselves are 7,000 kilometers on a side, which is basically, if you were to put Australia and the US together, that's about how big it would be, because it's about twice the size of US and twice the size of Australia. So
to put it in perspective.
Yeah. So those are the images that we're looking at.
And thanks for that, Jeff. That really helps.
Mm-hmm. So Jupiter's atmosphere is much like ours. It's just that their clouds are made of other things than water. There are water vapor clouds. It's just and this is kind of standard image here, and it shows all of the features that we'll be looking for.
So beautiful.
Yeah. But here are the different cloud layers.
He said, "Oh yeah, that is a big chunk of yeah."
Yeah.
Cool.
Well, but it's a little chunk of Jupiter.
Yeah, it's a little chunk of Jupiter.
Yeah.
Big picture.
Yeah. And it looks small on the screen, but yeah, it's out of a big territory. Okay, so you've got mostly ammonia clouds that you're seeing, and the ammonia clouds are bright white. I think even brighter than water vapor clouds.
Oh, okay. So the white, when we see bright white in the pictures,
it's likely ammonia.
Likely ammonia. Awesome. Yeah. That's a good way to say it.
Next layer is ammonium hydrosulfite clouds.
Well, that sounds bad.
Well, it's a key ingredient in stink bombs.
Okay.
So, yeah.
Probably doesn't smell great.
Yeah. Now, and then you find the water clouds underneath here. But we're not likely to see any water clouds in images because it's so deep in that we're just not going to see them.
So, do you have colors for us? You said
Yeah.
ammonia is very white.
Yeah.
How about ammonium hydrosulfide?
They don't actually say. And
Okay.
one of the things that they get into is that aside from ammonia clouds, it's very hard to tell what the different chemicals are on the clouds.
Okay.
Because some of the, and they get in more into it, but some of them they think are photosensitive chemicals.
Oh.
Like how the desert surface changes color from the sun.
Oh.
So especially like the brown color, the rusty brown color. Oh, hey, Michael.
Hi, Michael.
Um,
Thanks for joining us.
Yeah. The rusty brown color is possibly, and they're not saying that it is, but they're saying it's possibly caused by photosensitive chemicals that are changing color.
Very interesting. Okay, cool.
But that's not actually what they're looking for here.
Okay, I'll go back to the...
Yeah. So what are vortices? Yeah, they're cyclones. I mean...
So we're looking for weather on Jupiter.
Yeah, the vortices are essentially hurricanes.
Cool.
Oh my God.
But they're not made of ammonium, right?
Yeah, we don't have ammonia clouds.
No. That's cool, though.
Yep.
And I guess Cliff has been having weather, too.
Yeah.
Sorry, man.
Yeah. Okay. What are they looking for here? There's basically, unlike on Earth, where we have cyclonic clouds, which basically all spin in the same direction. On Jupiter, they have clouds that spin in both directions. Oh, wow. That's a bit warm.
Kind of warm, Michael.
Yep.
We had temperatures like that.
Yeah.
Not too distant.
But we don't have your humidity,
no,
so.
it's much nicer today.
Yeah. But, and one of the things is there a difference in diversity between cyclonic and anticyclonic features? I.e., are cyclonic cloud features much more diverse in color than anticyclones? Basically, are they different colors? So all of this is picking out things, and we're not making these determinations, but we're picking out things for the scientists to look at.
And I always love how they give you plenty of information so you can learn too. It's sort of a nice trade-off. You do, some of the crowdsourcing kind of work for them, and they provide some really cool information. That's the sort of thing you like.
Yep.
And Michael said it is stifling out. I bet.
Yep.
I remember it reminds me of a Cleveland summer.
Or Michigan, yeah.
95 and 95.
Yep.
Or 100 and 100.
Yep.
All right, back to the...
Yep.
Cool.
So, so basically, we're going to be identifying things other than just cyclones, but they're looking for cyclones here. My guess is that instead of just saying, is it a cyclone or not a cyclone, we're categorizing it so that other people who are interested in other features will have their own data set. They just aren't looking at those data sets right now, but we're building data sets for people who are looking for other things.
Well, there's two tasks involved with this. So this is one of them.
Yeah.
Is the other one?
The first task will be, what is this? What features are here?
Okay.
The second one is, what's the color of the cyclone?
Oh.
So we can tell right now that the first task, they're looking to isolate the cyclones, but they want us to classify any of the features just so that other people would have some data sets to work with.
Oh, that's really cool. So they're going to share their information.
Yeah. They don't specifically say it, but why else would they have us do that? You know?
Well, it makes sense. Yeah.
Yeah.
So your work will go even further. That's cool.
Yeah.
Should you choose to do this project.
Yeah. And they don't talk about it anywhere else but right here. But how are brown barges, which are elongated cyclones that have deep brown color, different from other cyclonic features? Are there non-brown barges? So something to look for, but they don't actually mention that anywhere else except right here. But apparently someone is looking for that.
That's an interesting way to describe that too. Like brown barges. is.
Yeah, and here, let me show
Oh,
you.
let me go back.
Yeah.
Oh,
Here,
the big. Okay.
The middle one right here with a long brown.
Mm-hmm.
It is a cyclone.
It looks
it
like
is a
two,
vortex.
actually. It looks like two that
Yeah, it could be. And it could be,
or something.
but it's brown.
Huh,
And
okay.
they don't know why, and they don't, they want to look for those. So I
Cool.
guess someone on this project wants to see these.
All right.
So, are certain cloud features tied with underlying dynamics? Do brown cyclones only form in certain shear conditions, etc.? By basically finding the colors of the cyclones in the second part, we basically give them, okay, here's a bunch of brown ones. Then they can look at those and study them and see what's the same or what's different between the brown ones and the non-brown ones. So there's a lot that they can do with these different data sets.
So on Jupiter, there is a lot of weather, and you can help.
Yeah.
Cool.
And
so if you like weather.
Yeah. And here's a bit about the Juno spacecraft.
Yeah, that's beautiful.
And here's a video of these are the orbits that they're taking, and they're only taking the shots as it zips around. So the shots that we're seeing are the near passes.
And I think they had to do this because of the radiation from Jupiter.
Yeah,
right?
They couldn't stay in there very long.
Yeah, right. But it should accumulate. I mean, even if they go.
Yeah.
Anyway.
But basically, while they're zipping around, it's actually taking shots, but they're actually accumulating photos faster than they can transmit them. And they don't say that here. I just remember Juno,
okay.
The Juno mission. And so throughout this entire rest of this thing, they're transmitting some of the photos that they took in the first, while on their near pass.
Oh, okay.
They're also taking a look at any moons that get close to them as they go. As you see, the moons are relatively zipping around there.
We got some comments. I want to take a break and talk about those.
Sure.
All right, so let's see. Michael says, I joined late, so I didn't know you were talking about outer space. Yeah, this is, I'm going to go back to it. Jovian Vortex 100 is a Zooniverse project.
Yep. And we're, basically looking for features on Jupiter's surface or Jupiter's cloud layer.
The weather, yeah. All right, Scott, I love this. So when I go to the bar and someone asked me what I did for the day, I could say I counted cyclones on Jupiter. That would be hard for anyone else to beat. Yep. Love it.
You won't actually be counting them, but you will be finding them. You will be circling them. But
and maybe to get an idea where to drop another probe. Oh, yeah, you know what? I can completely believe that. And things probably we don't even know about happening. Right. So there's lots of projects always kind of in work. And
yep.
Are we going back to the...
Yeah.
Okay, cool.
Because this is, and now we're getting to that last shot was neat, wanted live for that. But this is why I wanted us live. Because this is a compilation of one of their passes.
Oh my God. It was like being in orbit around.
Yeah, basically as it's doing that near pass.
Is that a real time? That's fast.
Well, I don't know if it's real time.
Okay. A lot of times they'll speed these up for NASA because they can be, a little tedious to wait for.
Well, and if the shots aren't being taken at video time frame, if they're like a second apart, it'd look really choppy. So they're doing them at frames per second, so that it looks smooth to us.
Got it. Okay.
So that's why I'm doing this live. That was it right there.
Got it.
But
cool.
Since I wanted to do that live, might as well do the rest of it live.
All right.
So how can you help? Basically spot features, and they'll go into that. They have a pretty darn good tutorial for both sections.
Awesome. Okay.
And so then we go back up to the top, and the team, fairly small team for some of these. I mean, the last one I did had, like 20 different people on it.
I remember.
But here we got.
And some of them only have two or three.
4, 5, 6, 7. So that's
I really like that they talk about the people, I mean, you can certainly read up about them,
Hmm.
and they are often, I think, in the chat part of it, right?
Yeah.
The forums.
Yeah.
So yeah, if you get into this and you want to talk with them,
Mhm.
I bet you could.
Yeah.
But they'll be in there at times, or you can respond back and forth, that kind of thing.
Yep.
What's next?
Okay, the FAQ.
Mm-hmm.
FAQ. Why study the atmospheres of other planets? And this is what brings it home. And because essentially they're saying that the atmosphere of Jupiter's like Earth's, except on a much bigger scale.
Mm-hmm.
You know, things is much more energetic, so things happen there that don't happen here, or happen much more visibly there than happen here.
Okay.
And so if the models that we made for Earth can actually work for Jupiter, then they're, and if we tweak them to work for Jupiter, then test them against Earth, we build our own atmospheric models much better.
Oh, okay, cool.
What's our atmosphere made out of? Unlike Earth's, it's 87% hydrogen and about 13% helium.
Okay.
So
could have been a small star, maybe.
Yeah.
Cliff goes, the satellite would be moving very fast in the flyby.
Yeah. In
Right.
the near, yeah.
Yeah, and I know there's an equation about
Mhm.
where things are on their orbit, and there's some equals there. So it might be close and fast, far away and slow. Yeah.
Yeah.
I remember looking at that.
Mm-hmm. So, what is Jupiter's atmosphere made of? Oh, we just talked about that. Got distracted. Sorry, folks. That never happens. But, I would imagine that there is hydrogen there, but it's such a heavy gas that it's probably pretty deep in, and we just can't see it.
Okay.
And there, the remaining fraction is heavier components such as ammonia, methane, water, phosphine, hydrogen sulfide, and of these heavy elements. I like the fact that they're calling methane a heavy element and water a heavy element.
It's heavier than hydrogen and
Yeah.
helium.
Yeah.
By far.
Mm-hmm. Just puts a different perspective on it.
Well, it's even, I mean, methane can sink in lakes, and then there's problems. So it's kind of heavy.
Mm-hmm.
Right? Isn't that the thing that if it comes up, it could explode? That kind of.
Well, usually it's underneath a layer of something.
Okay. All right. Got it.
But there are methane lakes on Titan.
Oh, right.
What are the Jupiter clouds made out of? And this research page, which points back to here, so it doesn't matter. That wasn't, that didn't help us. Where the different colors come from. Here's where ammonia clouds are the bright white clouds.
Okay.
There's a lot of debate about the exact nature of the reddish and orange clouds. Oops.
Cliff goes, just depends on how
cold.
Oh, here it is. Cold.
Yep.
Okay. That makes sense.
Yeah. So, so they're saying that the reddish orange could be from UV radiation. This is known as the creme brulee model, since the color is being baked onto it. But they don't know that that's actually true, but that's what they're thinking.
Lots of puzzles to solve still.
Yep. How can you tell if a cloud is made of water, ammonia, or ammonium hydrosulfate? And they're saying that's pretty difficult to determine. There could be some other, trace element in there giving it the color. And that water is very rarely seen since it's heavier than.
It's heavier than.
Yeah, than hydrogen and ammonia.
And Cliff comes back. Oh, that never happens. Yes.
Yeah. You don't know me very well, Cliff. Actually, yeah, you kind of sort of do. But do Jupiter's clouds produce rain or snow? This again has nothing to do with the project, but these must be questions that they get.
Still a pretty cool question. Yeah.
They're several evidences of thunderstorms. Yeah, because we've seen
Yes,
lightning
right.
on Jupiter, and the simulations say that there is.
Mm.
But the trouble is that any rain or snow will be underneath the clouds that are between us and the rain or snow.
Okay, yeah. Heavy.
So we can't really see it.
Right. But we determine a lot of things from like spectrum
Mm-hmm.
and when a planet goes in front of
Right.
a sun, its star, again we compare the
Yeah.
spectrum and determine different things. So
Yeah. And all of their models say that yes, there is, but we can't see it because the clouds are in the way.
Okay. And modeling can be very helpful too.
Mm-hmm. Yeah, basically because if the modeling that we use for Earth predicts the stuff that we see in Jupiter
Mm-hmm.
and vice versa, then the
Mm-hmm.
modeling also says that there's rain and snow.
Yeah.
You know, so
Yeah.
not
That's
100%
logical.
proof, but
Right.
it's
Pretty
logical. Good evidence.
It's logical.
Yeah, it's evidence, not
Yeah.
proof. How do vortices form on Jupiter? Similar to hurricanes and cyclones, it causes the Coriolis force to act on the moving clouds, starting to them rotating. The project, and here's where each image measures about 7,000 kilometers on a side. So,
Right. The comparison
mm-hmm.
with United States and
Canada
and Australia.
Yeah.
Good.
So, and then here's what they say what they're doing, and we already talked about it. They're working on their cloud or their atmosphere simulations.
Okay.
Why do different images have different color balancing? There are 3 different color filters, red, green, blue, that are then combined into a color image during the post-processing. Therefore, it's not a true color representation of the data. The combined color images are modified in a way to mimic what we would see.
Yeah, and that's pretty much true of a lot of these telescopes. Hubble, and of course the James Webb Space Telescope now is bringing back infrared, which we can't actually see, so they have to convert it to something we can see.
Well, and
so they're all
in some cases they're just stepping it up into our range, because what happens with things that are moving away from us is that visible light drops down toward the red, and they're looking at some of the farthest things, so the visible light there would be infrared. So so in those James Webb images, if they step the color up, that is what we would see. So that's
so they basically shifted.
Yeah.
Sounds like okay.
Yeah. So that's cool.
Yeah, I don't know in particular about James Webb, but yeah.
Yeah.
And maybe some of the audience will, because I think a lot of people have been following that lately.
Yep. Okay. And who do I ask if I have questions?
Oh, there you go.
Yeah. There's an unusual vortices talk board too.
Oh, cool.
Yeah. And I saw one that looked like a duck once.
Wait, what?
Yeah.
You saw one what? That looked like
a vortex.
Okay, so okay.
I was thinking that's got to be 2 vortexes, one eating the other or something. But
yeah. Okay.
Okay. So then there's the field guide.
Alrighty.
And unfortunately, they have everything mixed up here. They don't have like first project, then second project.
Oh, it's all there together.
Yeah.
Got it.
So we'll get into that, and I'll look at the ones that apply to each one.
Okay.
Then the classify.
Which is the typical place to go and do this task, yeah.
Yep. And so here's the tutorial.
Gosh, what a beautiful picture that is. I mean,
yeah,
that could be on Earth.
Yeah.
It's amazing.
And we'll get to that one because that's one that there's nothing to see here. There are no features.
Okay.
But,
got it.
Okay, so welcome to the workflow. Okay, this is what we're looking for. Vortices, 1 or more. Turbulent region, which is basically, you've seen it around the bands where they just have lots of features, but none of them are actually vortices. Cloud bands. Oops. Yes, that duck. where the image is featureless, which is what is behind here right now, where the image is too pixelated or distorted, because occasionally the image gets bunged up. But you can choose up to 2 of these.
Oh, interesting.
So if it has turbulence and vortexes, or if it has bands and vortexes, or bands and turbulence, you can mark both of them.
Oh, okay.
So that's cool. And so that's a vortex. Generally a circular or elliptical shape, hurricanes on Earth. And so these are just different examples of vortexes. Turbulent region. Let's go up here.
That looks turbulent.
Yep, that's a turbulent region.
No specific vortex or anything, yeah.
And even if there is, it's still a turbulent region, so you would mark both.
Oh, got it. Okay.
Yeah. Images should be labeled with the vortices option and the turbulent region if they have both. So here's like turbulence plus vortex. And here's an example of only turbulence, although that looks like a vortex to me.
Sure does.
Actually, the one on top, that's a only turbulence, but hey.
Right.
Cloud
and again, that's why they have a lot of people, seeing each image and classifying them. And I think if there's lots of conflict, they get someone specifically versed in this, an expert to examine it directly, which, and you think about it, that pares down their work. They know that that's the stuff they want to concentrate on because it's different. We have conflicting crowdsourced
people can't tell, so get an expert to look. And why can't they tell? I mean, is it some weird combination of the two? So so they want to know that too. Here's cloud bands.
Oh, okay.
And these are everyone knows about Jupiter and Saturn, because the best images that we had before just had bands.
Right.
Before we started pointing the big, throwing big guns past it, that's all we really saw of Jupiter.
Hey, if you got a second, Daniel joined us. Sure. Hi, Daniel. Thanks for joining us. Glad you're here. Does Jupiter have the strongest magnetosphere in the solar system? Would it potentially provide the best cosmic ray shielding for humans?
Yes, but it doesn't matter. Because the magnetosphere is so strong that it'll kill you.
Yeah.
So you kind of can't win there. Yes, cosmic radiation isn't going to bother you. It doesn't matter. You'll be dead.
All right. We got one more from Cliff. The North and South poles are full of vortexes. It's just weird. And Cliff had wonderful pictures on Facebook, I noticed earlier.
Yeah. And some of them are like hexagons and stuff like that, which is
interesting, because I've noticed in stirring stuff into my cup, I looked at the one day and I was like, hey, that looks like the spot in Jupiter. And it's like, so maybe that's sort of a natural occurring thing. I mean, no real correlation. It's just something I noticed and thought, oh, isn't that interesting?
Okay. So cloud bands.
Those seem pretty self-explanatory.
Yep. And sometimes it just looks like
nice clouds.
Like a typical day at Cliff's place. Yeah.
Sorry, man. Yeah, for someone who's got as many telescopes as Cliff says, that's a bad day.
Yeah.
That's a hard thing to deal with.
Yeah. And here's cloud bands and vortices.
Oh, interesting.
Some cloud bands. And there's some vortices like right there. So in turbulence and vortices, cloud bands and turbulence. It just basically, there are combos.
So pick up to 2.
And then this is something that I don't think they're doing on this workflow. Vortices and turbulent filaments. Finally, in the third workflow. Oh, okay. There's going to be a third workflow.
Oh, very cool.
We're going to be trying to determine which way it spins.
Boy, a big juicy project. Yay.
Yeah. So this is a gift that's going to keep on giving.
Nice. Well, they've probably got a lot of pictures.
Yeah. Yeah. So.
And here's the task.
Yeah. Well, here's the field guide. They tell you more about, like, here's vortices and stuff like that.
Ah.
Turbulent structures that are not vortices. Oh, here we go. This is one that we saw. Apparently, this is not a vortex.
Huh.
It's just a kink in a piece of turbulence.
Okay.
Kind of like it's not actually spinning around. It's just like kinked there. So, they can host vortices within filaments, though, like this and like that. So,
okay.
there's a bit of, and then
poor Cliff.
But
yeah, hexagons. That is weird. And yes, the sky gods are not in my favor.
Yeah.
Sorry, man.
Yep. So, folded filament regions. This is turbulence.
Okay, there's that picture again.
Yep. And cloud bands, what we're all familiar with from the old days.
Yeah.
So that's it that relates to what we're going to be doing today. And so this one, image is featureless. So we'll hit that. Say done. And I'm going to unzoom a little bit, just because that way I can get this whole thing on the same vertical. Okay. Again, unless anyone can spot anything in there that I can't.
Well, it seemed like the bands on the one picture they were saying.
Well, I don't know if that's a band or just a light feature.
Yeah, I don't know.
Yeah,
well, and you know, they're gonna have a lot of people look at them and they'll check them.
All right. Yeah, let's see.
Yeah, okay. He's ready for you, Daniel. Gonna have to fact check you on the supposed lethality of the Jovian magnetosphere. Do you have a source for that?
Not specifically. It's just a lot of things that. Well, for one thing, I know from talking to someone who worked on Juno itself that the reason why the orbit is like it is because they don't want to spend too much time in the magnetosphere because they were afraid that it would kill Juno. And Juno's, so it can't be good for us.
Yeah.
So.
Well, I'd be curious to see what you learned, Daniel.
Yep.
That'd be great.
Yep.
Cool.
So. Here we go. We'll go past this one. Oh, some turbulence.
Weather.
Because when I was doing this on my own, I only had one image where there wasn't anything going on, and then I'm doing it with you guys, and it's the first couple images. So
you get them, okay?
Yeah. So.
We got another one from Daniel. So it's like the Van Allen belt.
Yes, only much, much stronger.
Okay.
Yep.
It's a good correlation.
Yep.
All right. What else you got?
Oh, let's see. Here.
Sort of turbulence.
Well, turbulence is part of it.
Is that a band?
I'm wondering, I'm not actually seeing any vortexes. So yeah, I think cloud bands.
You can pick up to 2.
Yeah. So.
Oh, folded.
Yeah, turbulent region. Yeah. Is that a vortex?
Doesn't look like it to me.
Yeah. Yeah. Okay.
But it's fascinating.
Yeah. Okay. And so I'll let you guys do the pretty pictures later. Let's go look at the other workflow. Circle the vortex.
So that's where you find the 2 of them right at the the basic page.
Yeah.
Scroll down a little bit. They should be there.
Okay. Welcome to Circle the Vortex workflow. Basically annotate the images that you labeled as vortexes in the previous task, or that someone has, because they don't do just yours. So you pick the color of the interior of the vortex.
Oh, interesting.
Here, red, orange, white, brown, dark vortex. Basically, it's a hole or multicolor. And so here's red corresponds to the bright red orange color, brown. So these are both the red and brown kind.
Okay.
White vortices have bright centers.
Mm.
Dark vortices seem like they're a hole,
Mm.
and they might well be.
Okay.
And so this is and this shows how to do it, and it's
Oh, they're actually, you
yeah,
can pinpoint them circularly
yeah,
instead of a little square.
yeah,
Most of these are boxes.
yep. And if you notice, even though I've seen this, I discovered it on my own too, is that you don't have to move it around so much if you start in the center of the vortex and move out to the side.
Ah,
So that's just one tip there.
okay.
Um, so, and then here's multiples. You can do
Got
as
it.
many as you want. If you notice they're different colors here, and if they hang off the screen, you can do that too.
Oh, wow.
It's sometimes hard to do a circle off the screen, but if you get it roughly the right shape, you can then move it.
Oh, okay. This is actually pretty sophisticated. There's a lot to sink your teeth into here.
Yeah.
That's cool.
And so here we go. This is multicolored. For vortices that show two different colors in the interior, if you notice there's white and brown in the interior, they don't necessarily care about the rim. And that's really hard to tell them multicolored, because what's the rim and what's the interior? Do not use this option if either the interior or exterior color looks like a cloud clearing.
That's probably something you find in the field guide, the cloud clearing bit.
Yeah. So here's another example of multicolored vortex.
Mm-hmm.
Here's an example. Oh, here's one that might look multicolored but label this as white, because see, it's dark on the outside, but the interior is all pretty much just this part. And that's a dark vortex. So the white and the dark ones are going to be multicolored just because you're contrasting light and dark. So these are just either light or dark. It's when there's actual other color in there.
So Daniel's came back with something. You ready?
Yeah.
Do you know if these human-generated data sets potentially will be used to train machine learning / AI systems?
Likely. I mean, because part of it is that they're trying to check our own weather models off of Jupiter. And so they didn't say anything about doing that. They were just talking about their weather models. So
a lot of them do actually say, the computer will tell us this. We think humans can identify patterns much better. And so they'll be, training the computer with, people that come in and help them solve these questions.
Yep.
Awesome, Daniel. Thanks.
So here is the next section. If the vortices are out of frame, just let the circle go out of frame. And yep. And in the field guide now, you notice brown barge vortexes. They talk about that a little bit more. Bright anticyclone vortexes. And we're not looking for direction here. So we're just looking for vortexes, not direction. The third data set is, I think, going to be.
Yeah, sounds like it.
Yeah. So compact red cyclones, they look like red dots with stuff swirling around them.
There's a lot going on Jupiter.
Yeah. Dark vortexes look like holes. They probably are, but I guess they're not willing to say that without more study. Large red cyclones as opposed to little dots. Multicolored vortexes. And these are the ones that are going to be the hardest to classify. But if you notice, there's kind of a smudge difference in color. And now remember, they said that the dark, this reddish brown, could be UV radiation affecting it, which would mean that these would be the higher spots. But again, they don't know yet. So the multicolored ones are the most interesting to me. But
okay.
And pop-up clouds. This is just type of turbulence where stuff's coming up. Doesn't have anything to do with this one. It's just neat.
Okay.
Okay, so here we go. This looks like a multicolor to me. Yeah. So we'll call it multicolor. Go here. Let's, yeah, get it kind of there. What is the color at the center? White.
Kind of looks blue to me.
Yeah, but they don't have that as an option.
Okay.
So.
Oh, so you can pick it up and drag it too.
Yeah.
That's interesting.
That's if you pick your center wrong.
Oh, got it. Yeah. That's pretty good.
There. Yeah. So there we go.
Oh, there's a lot on that. Okay.
What is the color at the edge? Now, is this brown or red orange, do you think?
Yeah, they're kind of distinguished pretty definitely between the two, don't they?
Yeah. Man.
Yeah, I say just take your best guess. I mean,
yeah.
There's going to have lots.
So what's my best guess here?
They're going to have a lot of eyeballs on it. I wouldn't worry.
Brown.
I wouldn't stress about it too much.
Okay, so here we go. There's
I guess they've already classified these as vortices, right?
Yeah, they already know that there's a vortex in this image.
Yeah, or one or more, yeah.
Yeah. So let's get this one.
From the first part. So you're pretty sure you're going to have one or more in each image.
I don't see any more. These are just turbulence areas.
Folded things?
Yeah.
Okay.
There's a white one.
Yeah, a big one.
And you see it's off the screen.
Yep. Oh, and the image follows it. That's cool.
Yeah, so.
And the circle follows it, sorry. So it looks like a little bit of fiddling to get this properly sized up. Oh, Daniel says they should have a color palette. That'd be, well, go in and get on the forum and talk to them about that. I mean, these aren't static. They're not just the task. You've got people you can connect with through this Zooniverse project.
Yeah. Yeah, and I just find these fascinating.
Seems like a lot of white in the middle.
Yeah, but is that a multicolor?
Yeah, I don't know. Well, that's the task, isn't it? To try and help them figure this stuff out.
To be smarter than their computer.
Well, that's easy already, but
for some of us. Okay.
Oh, excuse me.
Okay. White interior. Brown. That's definitely brown.
Okay.
Okay. I think that'll do it for now.
All right. Well, that really looks like a great project, and plenty to work with, plenty to learn.
And pretty pictures. Yeah, pretty pictures.
Beautiful. Yeah.
Yeah.
Amazing how big they are.
Yeah. And remember, these images are 7,000 kilometers on a side. So, yeah. So, a lot of those vortexes are a good chunk of the size of our countries.
Yes. Yeah, there's lots to do. Yeah.
And there's going to be a third workflow here. So
yeah, that's wonderful. Anything else you want to say about the project, Jeff?
No, I've pretty much covered it. I just think that this is one of the prettier ones that I've worked on recently. So
yeah, some of them are a little drab, a little different.
Well, like the last one I did was basically, ooh, it's nice to have colors other than shades of gray.
Yes. All right. Well, so next segment, I am going to encourage you to get your free list of annual meteor showers. Go to meteorshowerchart.com, fill in the form, press the button today, and you will go to the website to get that chart. All right, so let's see what's next here. Oh, me. I'm talking to you about the stellar events. Oh, you got something?
Yeah,
oh, we got a comment. Yay.
Win valuable planetary prizes.
What'd I miss? What'd I miss?
I don't know.
Okay.
I don't know. Aside from looking at pretty pictures, I don't know if there's any prizes there.
Okay, all right. Oh, I was trying to get rid of it.
Oh,
I was trying to hide it. Oh, sorry. All right, so some stellar events this week. That's July 22nd through July 29th. The planets are still predominantly in the early morning. That will change, though, as summer goes on. The Globe at Night project continues. That goes till July 28th. Remember, that's a 10-day span, and you're going out taking pictures of, in this case, Hercules in the northern hemisphere and Scorpius in the southern hemisphere. So you take your picture, report to the site, and the idea is to help them understand light pollution in various areas. On July 22nd, Uranus and the moon are in conjunction. July 25th, it's a good time to get your meteor shower chart because there is a meteor shower coming up soon. On July 26th, Venus and the moon are in conjunction. 28th is the new moon. And then we're back to the Friday night show. We have decided to do an open mic night. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. Also, Mercury and the moon are in conjunction. And that is the night of the Delta Aquarid meteor shower that goes into the 29th to the 30th. You're going to want to look after midnight. These are the Delta Aquarids. They run from July 12th to August the 23rd, so you might see some anytime in that range. But the peak is the 29th into the 30th. And again, the best time is to look after midnight. This radiates from Aquarius. Their peak rate per hour is 10 to 20. The source is 96p, also known as a Mach-Holt. That's the comet that the debris field is coming from. So the moon is 1 day old on July 29th. This will be extremely small and will set very soon after sunset. So great for meteor showers. Then you're up.
Okay, other events and activities. The Space and Art Masterclass with Nahum. It will be every Wednesday in August. That's the 3rd, the 10th, the 17th, the 24th, and the 31st. And I'm sorry.
What happened?
Oh, he says he can't even see the moon. Oh, you just undid it.
Sorry.
I can't even see the moon.
Oh, no.
So so packed in that.
I was going to grab this and
Okay.
share it in the chat for
Yep.
a clickable link.
And then here, let me show you. This is their page here.
So beautiful.
Yep. Oops, I can't scroll that. Scroll this though.
There you go.
So it's for the first time, Cosmica director and artist Nahum will give a masterclass on space and art. For more than a decade, he's worked extensively with space agencies around the world, conducting space missions for artistic purposes, including zero-gravity flights and installation of the first interactive artwork of the International Space Station.
Now I'm curious to see what that looks like.
Yeah. And they're asking for €200 or $210, which,
it is available online, though, so it sounds like anybody anywhere in the world can participate. Yeah. That's the cool part.
Yeah. So just found this recently, so there y'all go.
Yeah, and that's actually thanks to Dr. Diaper, the space juggler. He mentioned that on Facebook. I was supposed to say something about last week. I blew it. So tonight.
Yep. Okay. Also, Kennedy Center Visitor Complex Scavenger Hunt.
Still going on.
It's still going on through the 7th. Visit 6 stations in the Science Center and collect your prize at the Information Center or the Space Shop.
There's the prize, Daniel.
Yeah, there you go, Daniel. 9th annual Science is Cool event. August 5th, 9 a.m. to 4 p.m. Pacific time, and that's a Friday, and I work that day. This is a cool virtual unconference for cool teachers.
I'm attending.
Yeah, and it's free. It's looks like fun.
Yeah, it'll be cool. I'll share with you.
Yeah.
I'll tell you what happened.
Okay. NASA's International Space Apps Challenge, the largest annual space and science hackathon in the world. Space Apps. They're calling it Space Apps 2022.
Yeah, they've been doing this for a while. Every year for a while.
Yeah. So October 1st through 2nd, 2022. Register events in person or virtually. And this is from their website. Last year, Space Apps welcomed over 28,000 registrants across 162 countries and territories using open data from NASA and their 9 partner space agencies. They tackled 28 challenges and produced 2,814 projects.
So you can be anywhere in the world and participate in this one as well.
Yep.
Let's see, what do we got? That one's in the fall, so we'll wait for that. So we will look for your comments for a couple minutes here still. But if you or someone you know has done something interesting involving space exploration, science, astronomy, like that, we would love to share live. Join us again next Friday, July the 29th, for an open mic night. We will give you a link. We'll invite you to come on the show and talk to us. With any luck, it will work. We've had trouble with this before. We will do our best to bring you on and have you here. We actually decided on a topic since it is July and we've got the anniversary of the Apollo 11 and also Artemis is coming up. We're going to talk about moon landing. So we'll actually have a focus and a topic for that. We'll invite you to talk about anything you really want to. We're kind of thinking in terms of a topic at this point. All right. Any other comments? Anything you want to say?
Nope. It just, Armstrong landing on the moon is what did it for me. I was really little. My parents said, watch this. It's important.
Yep.
And there you go.
That and Star Trek, I think, would be what I would call my major early influences. I guess I was thinking about something else too. We hopefully, with any luck, please keep your fingers crossed. Neil Simmons will be our guest on August the 5th, I believe it is. You said. August 5th. Yeah. All right, Cliff, what do you got for us? Okay. Best time for a beer. It's not too early there? Okay. Well, it's Saturday. I know. All right. Thank you so much for joining us, everyone. Scott, Cliff, Daniel, Michael. Who else? Anthony was here.
Yep.
We really, really appreciate you coming and joining us on our show. In fact, next week you could be on our show.
Yep. And we figured out that it's better if we cut the video resolution. We go into our settings and
Never
too early, apparently.
Oh, I see that part.
But we're gonna cut our video resolution so we won't look as good. I mean, sorry folks, but but that should leave more bandwidth for the sound.
Yeah, we're gonna test that out.
So anyone who has trouble with their sound quality should look at their settings when you go in it and set your video down.
Well, let's make sure that gets in the notes next time so we can mention it a couple times while we're doing the open mic night next Friday. Neil Simmons the Friday after that. And if you want to be on our show, let us know. Actually, I'm talking to somebody I know from Facebook, so we'll see if she can join us.
Oh, okay, cool.
Alrighty.
The first I've heard of this so far.
Yeah, I know. I just heard from her this afternoon.
Okay.
So thank you again. Have a great week, folks. We'll see you next Friday. Good night.